Alright, for number 1, for 1 through 9, they ask you to graph the functions, and then they ask for you to name the point of the coordinates of the inflection point. And the inflection point is this point right here, where the curve changes direction. So for the parent function, it would be right there, 0, 0. This is the point of inflection. So when the function transforms, whatever point you get right here at the end, that's your point of inflection, okay? So for this problem, we have that k is -3. So the only transformation we have is a translation down 3 units. So then that means y is going to change. So we're going to subtract 3 from all the y's. So I usually put it on above the column. And so the x's are not going to change. So the x's will be the same. And then for y, -3 minus 1 is -4. Okay, x does not change. And then -3 plus 0 is -3. And then x is the same, but y is -3 plus 1, -2. So the inflection point is this one right here. So I'll just put this is the one they want for the first part. And now we're going to go ahead and plot it. If you notice, I already have the parent function in green on the graph. And so now we're going to plot the blue points. -1, -4, 0, -3, and 1, -2. So connect them with the curve. It has to have this shape, okay? It's not a straight line, it's not a V, it's not it has to have this shape. Alright, for number 2, this cubic function has a k value of 3, so that means the graph is going to move up 3. And then the 2 here is the a value, so that means it has a vertical stretch of 2 by a factor of 2. And the negative tells you it's going to reflect over x-axis. So we can take care of the negative and the 2 at the same time. And remember, the a and the k affect the y, not the x. So when you apply the transformation, you do ay plus k to get the new point, to get the transformed point. So again, in this problem, x is not going to change at all. Okay? So that means that we're going to take, and I might need a little bit more space, we'll see. I'm going to take, see, the x's will not change because there's no b and there's no h. I mean, b is 1 and h is 0. And so I'm going to take -2 times -1 plus 3, -2 times 0, -2 times 1, and then simplify. So again, x, no change in x, so -2 times -1 is 2, 2 plus 3 is 5, and then 0 for x, -2 times 0 is 0, 0 plus 3 is 3. And then for -2 times 1 plus 3, that's -2 plus 3, so that gives you 1. So the inflection point is this one right here. That's the point where the graph changes direction. Okay? It's always going to be the one that corresponds to 0, 0. Alright, so I forgot to put my original function, my parent function, right here. The green one is the parent function, and the blue one's going to be the transformation. So -1, 5, 0, 3, and 1, 1. Notice how the direction of the points is opposite to the green one. This one, because of the negative, the reflection over the x-axis, so this one's going like this. and coming down like this. Okay. Because of the vertical stretch by a factor of 2, it's like pulled up. It's skinnier. It's stretched out more vertically. Okay, so there's your graph. All right, for number 3, we have two transformations. We have H right here and K right here. So remember, the H affects the X and the K affects the Y. So we're going to add 5 to the X's, because remember it's counterintuitive. If you see in my X minus 5, it's actually going to the right, not the left. So we're going to add 5 to the X's and subtract 2 from the Y's. Okay, with the K, you do what it says. All right, so let's calculate the new points. 5 minus 1 is 4. Negative 2 minus 1 is negative 3. 5 plus 0 is 5. Negative 2 plus 0 is negative 2. 5 plus 1 is 6. Negative 2 plus 1 is negative 1. And so here's our inflection point. That's the point where the curve changes direction. Okay, so again, as the other ones, you notice that I have the parent function already on the graph. And I'm going to use the blue to plot the new points, the ones for number 3. So 4, negative 3, 1, 2, 3. 5, negative 2, and 6, negative 1. Okay, so notice the graph translated actually, 5 units to the right and 2 down. So that 0, 0 point moved here to this position right here. Okay, so now we're going to connect them. And there it is. All right, for number 4, the 1/3 is the A, and the 5, or, well, it's plus 5 right now, but this is where we get the H, okay? So what this tells me is that there is a vertical compression by a factor of 1/3. So that means that the Y's are going to get multiplied by 1/3. And a horizontal translation to the left, 5 units. Okay, so 5 units to the left. So that means that the X's are going to be subtracted by 5, and the Y's are going to be multiplied by 1/3. That's what's going to happen. Okay, because A affects the Y, you do AY plus K, but since K is 0, all we do is multiply by 1/3. There's no, K is 0, so we're not adding or subtracting anything. And then the H affects the X. Okay, so let's go ahead and simplify or get the new points. Negative 5 minus 1 is negative 6. 1/3 times negative 1 is negative 1/3. Negative 5 plus 0 is negative 5. 1/3 times 0 is 0. Negative 5 plus 1 is negative 4. 1/3 times 1 is 1/3. So this is our inflection point. Okay, and now we're ready to graph. Notice that I counted every 3 little boxes, I counted as 1 unit because of that 1/3. Okay, so negative 6, negative 1/3 is actually going to be negative 6 over here to the left, and then one little box down because that's 1/3. Then negative 5, 0, and then negative 4, 1/3. So this gives you a better idea by numbering the X and Y axis the way I did, like how you can compare the green graph to the blue graph and see what the vertical compression, how it shows on the graph. So it's something like this, where it's moving, sorry, like that, like that. So notice no matter how much you're compressing or stretching, the shape remains the same. If the points are going up, that side has to go up. If the points are going down, that side has to continue going down. Okay? Okay, for number 5, we have three transformations. The A is 3, the H is -4, and the K is 3. The negative in front of the 3 over here tells us that there's going to be a reflection over the x-axis. So just like I wrote here the little formula we use to transform the points. Since B is 1, there's not going to be, no change here. But there is an H. So what that tells me is that I am going to subtract 4 from all the x's. And then for the y's, I'm going to multiply by -3 and then add 3. Okay? And remember, I can combine the negative with the 3 up here, and that way I take care of the two transformations in one step. So I'm going to multiply by -3, and then I'm going to add 3. I'm going to add the k. So maybe I should just show the step right here. Let me just show the step right here. So -4 minus 1 is -5, and then -3 times -1 plus 3. Okay? Then -4 plus 0 is -4. Then -3 times 0 plus 3. Okay? I'm just showing the step because it's two steps and I don't want you guys to get confused later on. For the x, it's only one step of subtracting 4, so I'm just doing, mentally. So -4 plus 1 is -3, and then -3 times 1 plus 3. Okay? So now we simplify that, and we get -5. -3 times -3 is 3. 3 plus 3 is 6. -4, bring it down or across. -3 times 0 is 0. 0 plus 3 is 3. And then copy the -3. -3 times 1 is -3, plus 3 is 0. Okay, so here you have your transformed points. The inflection point is this one right here. Oops. This one. So now I'm going to go ahead and plot it. Notice I keep the parent function on the graph so that when we finish we could always compare the parent function with the transformed function. So let's see, -5, 6, -4, -3, and -3, 0. Okay? Notice how the points are going down. So that means that the left side is going to go up and the right side is going to go down, right? So I usually start from the middle point, the point of inflection, and then curve into the point above, and then curve down like that. So that's the graph of the of number 5.